Hi, in this video we are going to see how we use completing the square in case the expansion of a circle equation is given. So we know that the general formula for equation of circle is x minus a squared plus y minus b squared equals r squared, for center being AB and r being the radius, right? So what happens if we expand these perfect squares? Well, this is going to be x squared minus 2ax plus a squared plus y squared minus 2by plus b squared equals r squared. And you're going to see that these expansions of the equation of the circle will be given as it's equated to 0. So you will see it like x squared minus 2ax plus y squared minus 2by plus a squared plus b squared minus r squared as being a constant number altogether. For example, this is an equation of a circle. So x squared, 2ax is here, like minus 4x, y squared is here, minus 4by is 6y here, you can see, and all this is just minus 3. Now, the question will be that how you're going to be writing the center and the radius for this circle. Let's work this out. Now, first of all, we have to chop this equation into parts. So we're going to deal with x part and the y part separately, ignoring the constant at the moment. We'll come back to this later. Now, for x squared minus 4x, I'm going to complete the square. So minus 4 divided by 2 is minus 2. So basically, I'm talking about x minus 2 bracket squared, which is x squared minus 4x plus 4. Now, here is a hint for you. It will take a long time compared to writing it immediately here if you try to expand this, like, x minus 2 times x minus 2, and that's going to be x squared minus 2x plus 4, and then you will simplify it and end up with this. Please make sure, instead of this, you just know that for any two terms, bracket squared, it is a squared minus 2ab plus b squared. Make sure you know this expansion, and actually it's not that hard. You just take the square of the first term and the last term, and in between you multiply the two and just double it. Now, as per the signs, if here it is minus, you have a minus here. If it's plus, this is going to be plus. This is always plus when it comes to expanding a square expression, right? So you must remember that a minus b bracket squared is a squared minus 2ab plus b squared, and if it is a plus here, only this sign changes, right? This will make your life easier. Now, for x minus 2 squared, we have this expression, but what I need is this expression, right? So I'm going to take 4 to the other side, so it's going to be x squared minus 4x on this side, right? That will be equal to x minus 2 squared minus 4, right? On the other hand, let's deal with y now. Well, this is 6 divided by 2, so it's going to be 3. So basically, I have to work on y plus 3 squared, which would be y squared plus 6y plus 9. And if I take 9 to the other side, I will have y squared plus 6y equals y plus 3 squared minus 9. Now, why did I take the constants to the other side? Because what I want is that I'm going to replace, let me get rid of this, these expressions here by the completed square forms. So basically, instead of x squared minus 4x plus y squared plus 6y, I am going to write this for this bit. You can see the equation. And I'm going to write this for this bit. So it will change into x minus 2 bracket squared minus 4 plus y plus 3 bracket squared minus 9. And then I have minus 3 here as a copy paste, right? So if I simplify this equation now, I'm going to write down x minus 2 squared plus y minus 3 squared equals, right, minus 4 minus 9 is minus 13, minus 13 minus 3 is minus 16, which I will take to the other side as 16. So now I can write the center being 2 to 3 and the radius being 4, because I have to take the square root of 16, right? And I ignore the negative value because in geometry we always have positive values for length. So that is the answer to this question. Another example. Actually, this is rather an explanation of something that you probably know, but it's worth mentioning again. So say if a point, let's say minus 2 to 1, is or lies on the circle, right, with center or with equation x squared minus 3x plus y squared equals 11, for example. So let's say this is the equation of the circle. If this point given is on the circle, if it lies on the circle, this means when you substitute the values, the coordinates here, to x and y respectively, you will get 11 on the left hand side. Let's see, that's going to be minus 2 squared minus 3 times minus 2 plus 1 squared, right? And that's going to be 4 plus 6 plus 1. So 11 equals 11. This is what we expect to find, all right? So if a point given is on the circle, or it lies on the circle, then it satisfies the circle equation. Thanks for watching.